Welcome to Lecture Online. In this example, we have to simplify two rational expressions and write it as a single rational expression. Since we have a negative sign here, that means we're subtracting the second rational expression from the first, which means we have to have common denominators. They don't look like they're common denominators, so we have to make them common. To do that, we're first going to factor both denominators. So we're going to rewrite this as follows. This becomes equal to x divided by, this is the difference of squares, so we can write this as x plus 1 times x minus 1 minus 2x, and when we factor this denominator, we're going to again get two binomials. We have an x and an x. Since this is a negative, this is a plus and a minus. The largest of the two must be the negative, so a negative 2 and a plus 1. Notice if I look at all these two denominators, I can see an x plus 1, an x minus 1, an x plus 1, so these are common here, but there's an x minus 2. So the smallest common denominator, or the least common denominator, can be written as follows. The LCD is equal to x plus 1 times x minus 1 times x minus 2. So what I'm going to do is I'm going to multiply the left fraction by the one that I'm missing here, the x minus 2. Of course, I have to do both the top and the bottom, numerator and denominator. And here I'm missing an x minus 1, so I'll multiply the numerator and denominator by x minus 1. Let me illustrate what we mean by that. Well, let me rewrite it so I have a little bit more room. So x divided by x plus 1, x minus 1, I'll leave a little bit of room right here, minus 2x times, or divided by, x plus 1, x minus 2, and leave some room there. So in this case, we're going to multiply both the numerator and the denominator by the missing term, which is x minus 2. Again, notice that if we cancel these two out, you end up with what we started with, so nothing really has changed. And over here, we're going to multiply both the numerator and the denominator by x minus 1. Again, when you cancel these out, you end up with what you started with. So again, we didn't change anything. But now we can see that we have the same common denominator, so the two numerators can be written over one single common denominator. So let's do that. So this can now be written as x times x minus 2 minus 2x times x minus 1, all over the same common denominator of x plus 1, x minus 1, and x minus 2. Now I just have to simplify the numerator and see if there's anything I can cancel out. See what happens. So I'm going to multiply this together. So this is equal to x squared minus 2x. And a minus 2x times x is a minus 2x squared. And a minus 2x times a minus 1 is a plus 2x, all divided by the same common denominator. And now we're going to combine like terms in the numerator. I have a plus x squared, a minus 2x squared, that's minus x squared. Have a minus 2x and a plus 2x, well, that cancels out. So I'm left with this divided by the quantity x plus 1, x minus 1, and x minus 2. And that's the simplest form we can write it. So that would be the final simplest form of our initial expression. Again, notice if the denominators are not the same and you have to add or subtract these expressions, then you have to make the denominator common. You do that by multiplying each fraction or each expression by the missing part of the lowest common denominator. And that's how it's done.